Imagine you're driving a car down the road at 60 miles per hour and suddenly a brick wall appears 50 feet ahead. Your brain screams, "Brake!" You slam on the pedal and you stop just inches away. Your brain evolved to handle threats that look like that, fast, loud and right in front of your face. For decades we've treated climate change like a sudden brick wall. We look outside, see a nice sunny afternoon and think, what's the big deal? It feels fine. Or worse, when a brutal winter storm hits, we laugh and ask, global warming, huh? The single biggest obstacle we face isn't technology or even politics, it's our own biology. Our brains are catastrophically bad at perceiving invisible cumulative threats. Today, we're going to rewire how we look at the planet's biggest crisis, not through the lens of political noise, but through pure, terrifying and ultimately hopeful maths. To understand why the climate is changing, we have to look at the invisible shield keeping us alive, the atmosphere. 99% of our atmosphere is made up of nitrogen and oxygen. They are completely transparent to heat. Sunlight streams through them, hits the earth, warms the surface, and that heat radiates back towards space. If nitrogen and oxygen were the only gases up there, that heat would just shoot right back out into the cold void of the cosmos. The Earth would be a frozen ice ball, about minus 18 degrees Celsius on average. Enter the greenhouse gases, water vapour, methane and our favourite troublemaker, carbon dioxide. They make up less than 1% of the atmosphere. Think of them as the stage crew of a theatre. There aren't many of them, but if they stop doing their jobs, the whole show collapses. CO2 molecules have a very specific atomic shape. When infrared heat waves hit them, they don't let them pass. They absorb the heat, vibrate and bounce it back down towards the Earth. Now, a lot of people make a simple mistake here. They think, well, CO2 is natural, plants breathe it, volcanoes emit it, why is a tiny little increase such a massive problem? And that brings us to our first major reality check. Imagine a bath. Water is pouring out of the tap, the faucet. That's nature releasing CO2 through things like decaying plants and animal respiration. The drain is open. That's nature absorbing CO2 through oceans and forests. For thousands of years, the tap and the drain were in perfect equilibrium. The water level stayed flat. Then the Industrial Revolution happened. We started burning coal, oil and gas, releasing millions of years of locked up carbon in a matter of decades. We didn't just add a little bit of water, we turned the tap into a hose pipe. Most of human history, atmospheric CO2 sat safely at around 280 parts per million. As of right now, we are hovering well over 420 parts per million. That's a 50% increase in the geological heartbeat. And here's the kicker that catches people out. Carbon dioxide has a long shelf life. When you emit carbon dioxide, it doesn't just disappear tomorrow. A huge portion of it stays in the atmosphere for centuries. That means the heat we are experiencing today isn't just caused by the emissions we made this year, it's the cumulative bill of every car, factory and power plant running since your grandparents were kids. It's an ecological credit card bill. If a warmer planet just meant warmer beach days, it wouldn't be an existential crisis. The real danger isn't the temperature itself, it's what the temperature triggers. Scientists call these feedback loops. Think of them like dominoes. Domino 1. The Arctic. Ice is white, which means it acts like a giant mirror bouncing solar radiation right back into space. We call this the albedo effect, but as temperatures rise, the ice melts, revealing dark ocean water underneath. Dark water absorbs heat instead of reflecting it, so the ocean gets warmer, which melts more ice, which darkens more water. It's a self-fueling engine. Domino 2. Permafrost. In places like Siberia and northern Canada, there are vast underground layers of soil that have been frozen solid for tens of thousands of years, trapping ancient organic matter. As that ground thaws, microbes wake up, start eating the organic matter and belch out massive plumes of methane, a greenhouse gas that is roughly 80 times more potent than CO2 in the short term. These aren't future predictions found in sci-fi novels. This is happening right now. We are currently watching Earth's natural thermostat controls start to break down. When people hear all this, the reaction is usually one of two extremes. Total denial. It's a hoax, nothing is happening. Or total despair. Oh, we're doomed, why even try? Both reactions are traps. The physics of climate change doesn't care if you're optimistic or pessimistic, it's just maths. And the maths work both ways. Just as warming is cumulative, solutions are exponential. Over the last decade, the cost of solar panels has plummeted by nearly 90%. Wind power is cheaper than coal in most of the world. Electric vehicle adoption isn't a trickle anymore, it's a tidal wave. We don't need a miracle technology that hasn't been invented yet. We already have the tools. The only question left is how fast we choose to deploy them. Climate change isn't a cliff we fall off tomorrow, it's a slope we are sliding down. Every single ton of carbon we decide not to emit flattens that slope just a little bit more. If you want to understand this crisis, stop looking for a dramatic Hollywood ending. Look at the data, look at the transition happening right outside your window, and realise that the story isn't finished yet. If you found this breakdown useful, hit that subscribe button, and thanks for watching, and I'll see you in the next one. Bye for now.